So in this video, I'm going to cover the properties of exponents, including natural number and integer exponents, meaning we're going to talk about negative and using scientific notation, and a little bit on putting together stuff with geometric formulas. So exponents are repeated multiplication by the same factor, okay, which is going to be the base. For example, 2 raised to the power of 5, or 2 with an exponent of 5, means that we are going to repeatedly multiply by the factor 2 5 times. Okay, so we're never multiplying by 5 here, we're multiplying by 2 5 times. Be careful when you see something like this, -3 to the power of 4. Exponents are tiny numbers, they have tiny arms, and so they can only control the number that they are directly on top of unless there are parentheses. So only the 3 is being raised to the power of 4, not the negative sign. If we put parentheses around, that negative sign is also being raised to the power of 4. Keep in mind what parentheses or what exponents really mean. 5 times y squared times x to the third means we're multiplying by 5, then we're multiplying by y twice, then we're multiplying by x 3 times. Now, if we have parentheses around some term and then an exponent, it means that whole term is going to get repeated that number of times. We can also use the distributive property, which I will show you later, of exponents. Here is a list of all the exponent properties. Okay, once you really understand what exponents mean, then using this list of properties is not something you have to memorize. Okay. So the first one is going to be the product of powers. If you have the same base raised to different powers and they're being multiplied, well, those powers are just telling you how many times to multiply by that base. So we can just add the powers together and multiply by the total number of times we're asked to multiply by that base. Okay. So for example, if we have 3 squared times 3 to the 5th, since this means to multiply by 3 twice and then multiply by that by 3 5 more times, then we can just multiply by 3 2 plus 5 times, which means multiply by 3 7 times. Okay. The power of a power rule is where if we raise something to a power and then raise it to a power again, we're just going to multiply those 2 powers. This is because, let's say we're raising 2 to the 3rd squared. Well, that means 2 to the 3rd times 2 to the 3rd. So that's going to be 2 to the 6th. Okay. The power of a product basically lets us distribute that exponent over multiplication. Now be careful, this is only a single term inside the parentheses here, so we can distribute that exponent. If this were addition or subtraction, we could not do that. Okay. And really the way this works, if you say 4 times 3 to the 3rd, means 4 times 3 times 4 times 3 times 4 times 3. Since multiplication is associative and communicative, we can regroup them to multiply by 4 3 times and multiply by 3 3 times. Negative exponent, just like the exponent means repeated multiplication, and negative exponent means repeated division. Okay, we'll talk about that more later. The 0 exponent means multiply by this number 0 times. So that's the same as not multiplying by that number at all, which is the same as just multiplying by 1. So anything to the is just 1. The quotient of powers. So if we have the same base raised to a power divided by that base over another power, we can subtract the powers. Okay. And then the power of a quotient, just like with the power of a product, we can distribute that exponent over the division symbol. So those are the exponent properties. Pause here and take some time to maybe come up with new examples and make sure you understand how these work. That's a good idea. If you feel like you understand them, then maybe you want to attempt simplifying these exponents, these expressions, or you can just watch as I go through and show you how to do them.